For this video, I'm going to first show a derivation of the Henderson Hasselbalch equation, and essentially this is another thing about buffers, and it's going to show your. We're going to use this equation to use them to get them. All right, or to use this equation to calculate them. All right, so essentially we're asking this about a buffer. What's my pH? And we're going to come across this equation that's going to help us with it. Now, remember, for a weak acid, my Ka value is my concentration of hydronium times my conjugate base all over my weak acid, my concentration. Now I can rearrange this equation for the concentration of H3O+, and that's going to be equal to Ka times my concentration of acid divided by my concentration of my conjugate base. All right? Now, I'm going to take the negative log of both sides. So I get the negative log of concentration of H3O plus equals the negative log of Ka times the constant that. All right. Now you can see this right here is pH. All right. So pH is equal to negative log Ka. All right. Now, there's some interesting properties of logs that are applicable here. The log of AB, not natural log, the log of AB is equal to the log of A times B is equal to log of A plus log of B. All right? So, if I make this equal to Ka and this equal to, all right, this piece here equal to B and this piece equal to A, I can separate this into this. pH equals log, or the negative log of Ka plus the log of HA over A negative. I made a mistake. This should be negative. Because this here, it'd be like, so that it distributes to both of them. So it's negative log Ka minus the log of HA divided by the concentration of weak acid conjugate base. All right, so I made a mistake there. Now, there's another property of logs that is going to be important. The log of B over A is equal to the negative log of A over B. So, if this is this, then I can flip it and get rid of this negative. And then that becomes pH equals the negative log of your Ka plus the log of my conjugate base divided by my concentration of weak acid. Now, this thing right here is my pKa. So pH is equal to pKa plus the log of conjugate base divided by conjugate acid All right. Now, this is the Hasselbalch equation. This is going to allow us to predict the pH of a buffer. Now, you just simply plug in your concentrations of your base and your acid here and add it to your pKa value. When these two things are zero, or starting to zero, when they're equivalent, that's like that half equivalence point, then your pH is just equal to your pKa. All right? And when you've got more conjugate acid, all right, this is going to become a negative, and that's going to make your pKa drop, or your pH drop below your pKa. When I've got more conjugate base, this factor becomes positive, and it makes your pH go above your pKa value. All right, but that is the Hasselbalch equation, and that's what we're going to use to calculate the pH of a buffer. All right, you would essentially going to use this equation.